In this review video, we're going to talk about evaluating logarithms. So now that we have this new function called a logarithm, we're going to be able to plug in values and then get out an answer. Just like all our other functions, we plug in stuff and get stuff out. All right, to do this, we just need to remember that they're related to exponents. All right, let's say we want to evaluate log base 2 of 16. It's going to be equal to something. Let's just call it a for now. All right, if this was true, we know we can always rewrite an exponential expression using exponentials. It's going to be 2 raised to the a equals 16. Right, the 2 stays, the input and output switch. So really, when you're evaluating a log, you're asking yourself, what exponent do I put on 2 to get 16? It's really important to think about exponent, which deals with multiplication, but it's not just multiplication. So the answer is not going to be 8. 2 times 8 is 16, but we're thinking about what the exponent is. The answer ends up being 4. All right, 2 to the 4th equals 16. 4 copies of 2, 2, 4, 8, 16 equals 16. So my final answer is this logarithm is equal to 4. 2 to the 4th equals 16. So log base 2 of 16 equals 4. Log base 3 of 27. Again, I'm always thinking about exponents whenever I'm doing logs. I'm asking myself, what exponent do I put on 3 to get 27? That's going to be my answer. And the answer is 3. And why do we know that? We know that because 3 cubed is 3 times 3 times 3 actually ends up being 27. I've got log base 10 of 100,000. What exponent do I put on my base 10 to get out 100,000? The answer is 5. 10 to the 5th. Just count the number of zeros, 1, 2, 3, 4, 5. That ends up being my answer. All right, so the important thing here is just whenever you're dealing with logarithms, you always think about exponents. All right, not just multiplication, but exponents.